Hello, I'm Chunhyuk Jung from Dongguk University GTM Lab. The paper I will review development of fundamental pattern explanation methodology based on technology knowledge flow. Here's the bibliographic information of the paper. The paper was published in EPJ Data Science on 20 November 2025. The keyword and research objective are as follows. The table of context is organized to match the structure of the paper. Technological innovations stem from fundamental pattern, and identifying this pattern is important for understanding the origin of innovation and the direction of technological development. Previous studies have used methods such as expert judgment, citation analysis, and IPC code, but these approaches have limitations in fully capturing pattern characteristics. Therefore, this study analyzes problem-oriented and directional technology knowledge flow to present a new perspective for identifying source patterns. This study aims to propose a semantic methodology that transforms pattern text into the subject, action, object, or SAO structure to trace the flow of technological knowledge within patterns. The research concept consists of the following 3 points. Fundamental patterns are foundation technologies that drive innovation and support later technological developments. Previous studies have described them as basic, core, important, or root pattern, but commonly view them as the bias of technology flows and subsequent innovations. Based on previous studies, this research defines a fundamental pattern as a pattern that creates a technology flow and serves as its foundation. SAO structure represents pattern sentence in a structured form that help extract technical knowledge. In previous study, the subject was treated as a solution and the object function as a problem statement. Based on this structure, researchers analyzed similarity and originality by comparing semantic difference across documents. The study also used the SAO structure to organize knowledge unit and trace knowledge flow. Network analysis is used to identify technical problems and evaluate the fundamental nature of pattern. In this study, modality analysis is used to detect problem-based communities. Centrality analysis measures important nodes in knowledge flow, and main path analysis examines the evolutionary trajectory and path dependency of technology. Through this method, the study identifies patterns that play a key role in the development of technological knowledge. The study explores the relationship between semantic technology knowledge flow in pattern and proposed a methodology for identifying fundamental patterns. In this step, pattern data were collected from the USPTO database using a search query related to the target technology. Because this study analyzes technological knowledge flow through text, the claim section of each pattern was extracted as the main unit of analysis. In the preprocessing stage, duplicate data were removed, and the text was normalized through lowercasing, stemming, and lemniscation. Then the Stanford parser was used to extract SAO structure from pattern claims. After that, the action terms were standardized with a structure synonym dictionary and classified into functional categories based on the hierarchy. In this step, the study constructs a co-occurrence network to identify the scope and structure of technical problems. The Lowen algorithm is then used to detect clusters of closely related AOs, which are interpreted as groups of technical programs. Finally, representative AOs and related patterns are identified as the bias for exploring major technical issues and fundamental patterns. In this step, source patent candidates are first identified from claim containing core AOs related to technical programs. Then a technology knowledge flow network is constructed based on shared SAO structure between patents. Finally, fundamental patents are evaluated using for perspective, applicability, originality, path dependency, and marketability, and these indicators are combined into a final score. This study validates the fundamental patent search methodology from two perspectives: process-oriented patent and device-oriented patent. For the process perspective, it focuses on CO2 capture technology, and for the device perspective, it examines wearable device. Among wearable technologies, the study specifically selects wearable watch technology as the representative case. In the first step, patent data were collected from the USPTO using search queries for CO2 capture technology and wearable watch device. A total of 2,701 patents were identified for CO2 capture and 1,804 for wearable watch devices. The patent texts were then preprocessed with the Stanford parser, and SAO deflect were extracted and normalized to simplify the technical structure and improve interpretability. In the second step, technical problems were identified through modality analysis of the AO co-occurrence network. Using the Levine method, 11 communities were found for CO2 capture technology and 9 for wearable watch device, showing clear community structure in both fields. For CO2 capture, the main problem areas included pressure control, signal detection, and observant management, while wearable watch technology showed issues related to functionality, device coupling, user movement sensing, and display input integration. In the third step, Phantom were classified by major technical problems and reorganized into SAO format to construct the Phantom network. Based on logistic as computing, first Phantom candidates were selected from Phantom in the first 16% of the predicted technology adoption cycle. The final fundamental Phantom score was then calculated using entropy weighting. A fundamental patent for CO2 capture technology are summarized by topic with one representative patent identified for each program area. For example, US 4433981 was selected as the fundamental patent for topic 11, which is observant management. Fundamental patterns were also identified for each wearable watch topic, such as signal transmission, interface design, user location detection, and movement tracking. In addition, the ranking results for shield capture topic 11 show how patents were selected based on their fundamental scores. For validation, the study compared its results with previous research on CO2 capture technology. Unlike earlier studies that classified technologies mainly by observant type, this study identified more specific technical issues through modality analysis. In addition, Pinton highlighted in previous study were also ranked highly in this study, supporting the validity of the proposed methodology. The study also compared its method with citation-based approaches. The results show that highly cited patents often lead to broader technologies rather than the core technical problems, which highlights the limitation of citation count for identifying fundamental patents. The study further showed that high centrality in citation network does not always indicate fundamental innovation. Its fourth evaluation result also gave the proposed method the highest average rating in both CO2 capture and wear watch fields, supporting its effectiveness over conventional citation-based approaches. The study proposed a new methodology for identifying fundamental patterns by analyzing technology knowledge through semantic analysis. Unlike traditional citation or bibliographic-based approaches, it considered the specific problem and technological essence of patent. The results show that the proposed method is more effective in identifying fundamental patterns and can provide both academic and practical contribution. However, the study is limited by subjective expert judgment and the use of only USPTO data. The study proposed a methodology for identifying fundamental patterns through semantic technology knowledge flow analysis. It introduced an SAO-based approach that improved on conventional citation-based methods and identifies fundamental patterns more effectively. The study also provides academic and practical contribution, but it is limited by subjective expert judgment and the use of USPTO data only. Future research should improve automation and expand the analysis to patent data from other countries. This concludes my review. Thank you.